Hi everyone, my name is Rashdan Nur bin Rasman. In this video, me and my group, which is Muhammad Azri Nakyuddin bin Adias, Muhammad Hadi bin Muhammad Isa, and Muhammad Izzat bin Muhammad Rosli, will give a brief presentation on our final project, which is sodium versus lithium polymer battery. And our supervisor is Madam Nurul Ilham Binti Adam. These are the outline for our presentation. First of all, for this final year project, our focus is to study the properties and the advantages of sodium-based and lithium-based polymer battery. The purpose of this research is to determine the capabilities of battery using the lithium or sodium as main raw material using various methods and electrolyte to obtain the most favorable battery with its function. In order to determine the best battery, we are conducting research on the ionic conductivity and voltage stability of sodium and lithium polymer battery. Aside from using lithium polymer battery, which is widely used nowadays, sodium metal batteries or NMBs are among the most promising alternative to replace lithium ion batteries. However, because of the thermal instability and potential leakage, still pose severe limitation to this technology. Therefore, a moderate research on implementation of sodium polymer battery is still conducted for future use.
Assalamualaikum. My name is Muhammad Izzat bin Muhammad Rosli. I'm going to be talking about the introduction and the literature review. Okay, for the introduction, sodium and lithium polymer batteries are secondary type of battery where it can be rechargeable. The person who is the founding father for lithium polymer battery is M. Stanley Whittingham. The research followed from lithium ion battery in 1980s. The research produced polymer battery by changing the state of the electrolyte and synthesize with other substances that relate to the purpose of the experiment. The polymer battery can be categorized as three types, which is solid polymer electrolyte (SPE), gel polymer electrolyte (GPE), and composite polymer electrolyte (CPE). Next is about literature review. Lithium-ion battery was first produced by the Sony Corporation in 1990. The battery works using electrolyte which act as the ion transport pathway. The cell capacity, working temperature, range safety issues, and cycle ability of lithium-ion batteries are influenced significantly by the selected electrolyte and methods such as gel polymer electrolyte, GPE, solid polymer electrolyte SPE, composite polymer electrolyte CPE. According to Long-Lison 2016, concentration in excess of 50 weight% salt leads us into the area of polymer in salt electrolytes. An ionic conductivity of up to 10 to 4 Siemens per centimeter at ambient temperature could be achieved. According to Qiao Lingjin et al. 2020, SPEs are considered as appealing electrolytes for developing all solid-state sodium batteries due to their low density, good flexibility and processability, and inherent safety and reduced side reactions, good interfacial contact with electrodes. According to Law Hu Mei 2022, the optimized DSPE delivered a good ionic conductivity 0.31 millisiemens per centimeter at 23 degrees Celsius, an extended electrochemical stability window, 4.5 voltage, and excellent compatibility with natrium metal. A symmetric cell could be cycled at 0.1 milliampere per square centimeter and 0.1 milliampere hour per square centimeter for 1000 hours. That's all from me.
Methodology. For first article, the first preparation of the SPE of NADFSI and NaDFOB for rocking chair sodium metal battery. The two salts of work which NaTFSI enhance ionic conductivity and thermal stability, and while NaDFOB extend the electrochemical window and inhibit the coercion of the AI current collector caused by NaTFSI. Leveraging the genetic combination of two salts, this new DSPE formulation open a new path for the next generation high performance and NMBS. So the next article in this word need to create a composite solid polymer electrolyte CSPE that is very flexible, soft, self-standing and stable by employing poly PPC as primary metric and Na super ionic conductor type as the active organic filler. The interaction of the LAGP filler with the PPC metric, which provide an excellent polymer inorganic interface and allow for fast lithium ion transport, is credited with the CSPE improved electrochemical performance. To suggest LAGP reinforced CSPE open up new possibility in ASSL LIB manufacture and engineering. The next method is solid composite electrolyte. Solid composite electrolyte SCE, which combine the benefit of solid polymer electrolyte and inorganic ceramic electrolyte, have a acceptable ionic conductivity, high mechanical strength, and favorable interfacial contact with electrode, significantly improve the electrochemical performance of all solid-state battery over single SPE and ICE. For the last method is a zeolite composite separator with a goal of improving the thermal stability and electrochemical properties of corresponding battery. The first invention method were used to create a zeolite composite separator with a spongy light structure based and on a heat polymer matrix and ZSM5 zeolite filler. Up to 180 Celsius, the separator has improved thermal stability and minimal shrinking. In addition of a particle quantity, ZSM5 zeolite improved the composite separator wettability and electrolyte absorption, allowing for more efficient lithium-ion transport.
Next is the result from our research. From the table 1.1, we can see various types of polymer electrolyte used for lithium-based polymer battery, and the conductivity is listed. Next, for the table 1.2, you can see various types of polymer electrolyte used for lithium polymer battery with the conductivity listed. For the table 1.3, you can see the combination of sodium-based battery and lithium polymer battery. For the first one, we use dual salt polymer electrolyte, DSPE. And then we have composite solid polymer electrolyte, CSPE, solid composite electrolyte, CSE, and others. We also have the ionic conductivity and voltage stability listed below. And the voltage stability is on average 4.5. For discussion, in the analysis above, we already discussed about the advantages of each type of battery using either sodium or lithium as raw material to produce more ionic conductivity using any method or polymer electrolyte. From the analysis from Li Yanling Wang and his friend, the ionic conductivity obtained is 1.04 times 10 power of negative 4, while the voltage stability value is 4.7 volt, which we obtained from their article. They use a zeolite or polymer composite separator method. Next is the analysis we obtained from the author Wang and his friend, which have published in 2019. The values for ionic conductivity and voltage stability obtained are 2.0 to 4.6 times 10 power of negative 4. And the voltage stability is 5 volt. Then for the final analysis for lithium polymer battery is from author Long and his friend, which was published in 2016 with values of ionic conductivity 4.5 times 10 power of negative 5 and 4.2 volt for voltage stability. The method used is dry-solid polymer electrolyte, and lithium polymer battery is suited for high power application. Lithium-ion battery, on the other hand, are more efficient and common than lithium polymer batteries. They are appropriate for large-scale use because they have a higher power level. We have obtained the data for sodium pi. The analysis we got and obtained is from the author Law and his friend, which was published in 2022. The values of ionic conductivity and voltage stability are 0.47 for the SPE5, 0.38 for the SPE10, 0.31 for the SPE20, and 0.24 for the SPE40, and the last one is 0.064 for the SPE100. For the voltage stability, according to the order, is 4.1 for the SPE5, 4.3 volt for the SPE10, 4.5 volt for the SPE20, 4.5 volt for the SPE40, and 4.6 volt for the SPE100. This shows an accurate reading. Then the second analysis we got and obtained was from the author Kiao Lizing and his friends, which was published in 2020. The values of ionic conductivity and voltage stability are 1.5 times 10 power of negative 4 and 4.5 volt. The method used is cation solid polymer electrolyte CSPE.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hadi bin Muhammad Isa. I would like to present about conclusion and reference. In conclusion, the most essential attribute of SPE is its ability to carry on more effectively and in greater numbers. The method and SPE used in this paper show that conductivity can be increased in a variety of ways. However, there are some drawbacks that can occur when mixing SPE with other compounds and salts. This article demonstrates that there are numerous ways to improve the efficiency of SPE and reduce the disadvantages of SPE in future research. Apart from that, each SPE has its own set of advantages throughout the analysis, such as better conductivity in a cool room and robust mechanical properties. We expect that SPE will be used in everyday applications in the future. Next, this is our reference. That's all from us. Thank you.